Let's take a look at isomers. The first type of isomer is called constitutional isomers. The molecules having the same molecular formula but having different structural formula with the atoms bonding differently. They are formed by attaching branch chains and functional groups and forming multiple bonds at different locations of a parent chain. Take a look at this example. We have three isomers here, and the first one is 1-butene. This one has a double bond between C1 and C2. Its isomer 2-butene has a double bond between C2 and C3. Another isomer is called 2-methylpropane, has a double bond between C1 and C2. Also, they has a methyl group linked, bonded to C2. The second type of isomers is called Cis-Trans isomers. Those isomers are stereoisomers. Single carbon-carbon bond rotates, but a double carbon-carbon bond doesn't. As a result, the groups on one side of a double bond cannot rotate to the other side. Therefore, the same groups attached on the different sides of a double bond form different molecules. The molecules have the same molecular formula attached at the same parent locations, but having different spatial configurations. Those molecules are stereoisomers. This example, let's take a look at the 2-butene. 2-butene has a double bond between C2 and C3. We have two stereoisomers. This one is called cis 2-butene. This one called trans 2-butene. Cis 2-butene has two methyl groups on the same side of a double bond. The trans 2-butene has two methyl groups on the opposite of the double bond. When the two methyl groups on the same side of a double bond, this compound is called cis isomer. When the two methyl groups on the opposite side of a double bond, the compound is called trans isomer. With the IUPAC naming scheme, the cis and the trans are written in italic font before molecular name to indicate the stereoisomers. The next type is called Enantiomers. Tetrahedral carbons bonded to 4 different groups are called chirality centers. Organic compounds bearing chirality centers are called chiral molecules. Chiral molecules and the mirror image molecules are enatiomers. Enatiomers are non-superimposable, just like a right hand and a left hand. This is the example. There's two different molecules. They are a mirror image to each other, but they are not superimposable, just like two hands, right hand and left hand. This carbon is a chirality center. Chirality center bound to 4 different groups. Chirality center also occur in cyclic compound. This is the example. In this compound, the C3 here is the chirality center. They bond to 4 different groups. Let's take a look at the Fisher projection. In drawing a tetrahedral carbon, the two horizontal bonds came forward, the solid wedges, and the two vertical bonds go behind, the dashed wedges. This structure is abbreviated by a cross formula. This cross formula called Fisher projection. Next, let's take a look at the optical activity and specific rotations. Ordinary light is a light wave oscillating in all planes. A polarizer is able to absorb all the planes but one, generating a plane polarizing light. This is the ordinary light beam. After they pass through the polarizer, and they become this, only one plane. This light beam is called a plane polarized light. This plane polarized light goes through a substance containing chiral molecules. This plane rotate either clockwise or counterclockwise. The plane of polarized light rotates when it passes through a substance containing chiral molecules. If the rotation is clockwise, the compound is called tetrahedral and labeled plus enantiomers. If the rotation is counterclockwise, it's called levorotatory and labeled as minus enatiomer. The two enatiomers rotates the plane polarized light to the equal extent but in opposite directions. Let's take a look at specific rotation. Rotation degree per concentration of a chiral compound and per unit sample length dm at a given temperature and a given wavelength is the definition of specific rotation. The unit of specific rotation is degree milliliter per gram per dm. It's an intrinsic property of a chiral compound. Lastly, let's take a look at the compounds with two or more chirality centers. A compound with one chirality center has two stereoisomers, a pair of enantiomers. A compound with two chirality centers has four stereoisomers, two pairs of enantiomers. This stereoisomers which are not enantiomers are called Diastereomers. Here, this the compound has four chirality center, so they have two pairs of enantiomers, 1 and 2 enantiomers, 3 and 4 enantiomers. In this scheme, 1 and 3 are not enantiomers; they are called diastereomers, and 2 and 4, 1 and 4, 2 and 3 are diastereomers.